Here we are going to learn Class A amplifier. We have taken a series fed Class A large signal amplifier. Why it is called large signal amplifier means this is nothing but a power amplifier, and because it has to handle large powers, we use a power transistor here. This is nothing but a series fed amplifier, a normal amplifier which we have studied earlier. The normal amplifier with power transistor will work as a power amplifier. So here this is the DC load line diagram. Graph sheet lo gistaru DC load line, and these two will indicate the AC load lines. These two will indicate the AC load lines and how your output will be coming out of these diagrams that we are going to learn now. First we try to draw the DC load line. So I am taking the input side and I am considering a loop from this to this. I am considering a loop from this point to this point. Again, this is having a negative terminal. Loop will be completed in this way. If you are considering output, VCC is common for both input and output, and in this way we can take the loop. So here we start with minus undi, a minus ground ga avutadi kabatti we will start with minus to start chestam. So minus VCC ఇక్కడ మైనస్ VCC, ఇక్కడ ఎంత డ్రాప్ ఉంటుంది అలా అన్నా వేయొచ్చు, లేదా ఈక్వేషన్ ఎలా వేయొచ్చు అంటే ఇక్కడ ఒక వోల్టేజ్ తెలుసు, ఇక్కడ వోల్టేజ్ తెలిస్తే ఇక్కడ ఉండే వోల్టేజ్ తెలిస్తే అంటే ఈ పార్ట్ మొత్తం వోల్టేజ్ తెలిస్తే దిస్ వోల్టేజ్ మైనస్ దిస్ వోల్టేజ్ డివైడెడ్ బై దిస్ రెసిస్టెన్స్ విల్ గివ్ ద కరెంట్ ఫ్లోయింగ్ ఇన్ దిస్ బ్రాంచ్. సో వీ విల్ రైట్ దట్. దాన్ని వేద్దాం, లూప్ ఈక్వేషన్ కంటే దాన్ని వేద్దాం. ఆ లూప్ ఈక్వేషన్ వేసి చూపిస్తాను, అది కూడా వేసి చూపిస్తాను. ఫస్ట్ దిస్ పొటెన్షియల్ VCC and this potential. What is the potential at this point is going to be VB, that is VCC minus VB. And enti this potential minus this potential divided by RB will give IB. So what we will get? We get the base current. So what you want actually, what we want actually is IC. We want IC. So from this IB we can get IC. So what is IC? IC is equal to beta IB. Beta will be given definitely. You can use that value to find IC. So what we got here? We got IC value. So we got IC value here. That means the value on the y-axis we got. Next is we are considering the output circuit. What is the output circuit equation is going to be? If you start from this, minus first consider cheyali, minus VCC, దీన్ని కూడా అలాగే రాయొచ్చు. ఇక్కడ ఏముంది VCE plus minus. So ఇక్కడ current is IC/RC. So what is the drop across this is going to be plus IC/RC. ఇక్కడ plus VCE is equal to 0. This is my equation number 2. This is my equation number 2. So what is VCE? VCE is equal to, when this goes to that side, VCC it will become plus minus IC/RC. So this is the value on this axis. So this is equation number 2. Now this IC and VCE, what we get during this calculation are nothing but Q point values, that is the quiescent point or DC operating point values. So here IC, first is the VCE, so VCE comma IC are the coordinates of this point, quiescent point, and according to the values we will mark that value point. Ante kada. Suppose VCE అనేది suppose ఒక 10 or 12 వచ్చింది అనుకోండి, we will mark according to the value. అట్లాగే IC ఎంత వచ్చిందో చూసి రెండింటిని ఇంటర్సెక్షన్ ఒక పాయింట్ ఉంటుంది, that point is called DC operating point. Now, so with a single line, with a single point, we can't draw the line. Straight line draw చేయాలంటే మనకి ఏం కావాలి, స్లోప్ కావాలి, ఒక పాయింట్ కావాలి, లేదా రెండు పాయింట్లు కావాలి. సో మినిమం we need 2 points. Here we don't know the slope. So minimum 2 points అంటే రెండు పాయింట్స్ ఎలా వస్తాయి? We can find 2 points very easily such that the point on VCE axis, the point on the IC axis we can find very easily. How we will get the point on the VCE axis? On VCE axis, IC is going to be 0. అంతే కదా. సో ఈ యాక్సిస్ మీద ఈ యాక్సిస్ కాంపోనెంట్లన్నీ 0 ఉంటాయి. అది ఇది x అనుకోండి, ఇది y అనుకోండి. x యాక్సిస్ రావాలంటే y should be equal to 0. So to find VCE, so IC should be equal to 0. So here if you take, now we take this equation. If you take IC equal to 0, this total quantity will be 0. So VCE is equal to VCC. And then we get a point whose VCE is equal to VCC, comma IC is equal to 0. So we got this point. Next, again if you want to find a point on this line, what we will do? We will take VCE 0 in this equation. In this equation we will make VCE is equal to 0. If we make VCE is equal to 0, what we will get? 0 is equal to VCC minus ICRC, and ICRC is equal to VCC. IC is equal to VCC by RC. So here this is the point whose value is VCC by RC. So what is the point? Point coordinates are going to be here VCE is 0, IC is going to be VCC by RC. So we will connect these 3 points to get the DC load line, and we design our amplifier such that always this DC operating point should be placed at the center of the characteristics. Whole characteristics మధ్యలో center ఉండేటట్టు చూస్తాం. Why we see that means, if the operating point or quiescent point is placed at the half of the maximum values of both VCE and IC, then we can have the maximum swing. We can have the maximum swing of the output voltage according to the input voltage. That means we can get large powers. So, however, this type of circuit is not useful because it won't get better efficiency. Power losses will be more and swing will be less, and the voltage swing or current swing, whatever signal swing is going to be very limited or restricted. But to proceed our analysis, to take on our analysis, first of all we have to start from the basic thing. This is the basic amplifier, power amplifier, which is called as Class A power amplifier. అలాగే ఈ Class A power amplifier కి ఈ మోడ్ తీసుకున్నాము. We can take any other amplifier also. Voltage divider circuit ఉండి, ఒక ఎమిటర్ రెసిస్టర్ ఉండి, ఒక కెపాసిటర్ ఉన్న amplifiers కూడా మనం తీసుకుని అనలైజ్ చేస్తాం. So in that these equations are somewhat different. Now we saw how to draw the DC load line. DC load line అనేది డ్రా చేయటం మనం చూసేసాం. Now what are the quantities we need to draw the DC load line is that the first thing is DC operating point, which is also called quiescent point. What is the meaning of quiescent? Means a silent point. That means అంటే నీ వేవ్ ఫామ్ ఏం గడబడి చేయకుండా, ఏమి క్లిప్ అవ్వకుండా, క్లాంప్ అవ్వకుండా నీ వేవ్ ఫామ్ డిస్టార్షన్ లేకుండా వస్తుంది. సో ఇట్ ఈస్ ఎ సైలెంట్ ఆపరేటింగ్ పాయింట్ అన్నమాట. సో వీ హ్యావ్ డ్రాన్ దిస్. నెక్స్ట్ హియర్ దీస్ టూ సర్క్యూట్స్ విల్ షో దట్ యూ కెన్ అబ్జర్వ్ సంథింగ్ హియర్. Here this is nothing but your signals current swing. Your signals current swing. That means the output signal, the output signal will vary between the values of IC from this point to this point. ఈ రెండు పాయింట్స్ మధ్యలో నీ అవుట్పుట్ కరెంట్ విల్ vary. So this is the input signal. ఇది ఇన్పుట్ సిగ్నల్, ఇది అవుట్పుట్ కరెంట్ వేరియేషన్. ఇక్కడికి వచ్చేటప్పటికి ఏమవుతుంది, దిస్ ఈజ్ ద అవుట్పుట్ వోల్టేజ్ వేరియేషన్. వోల్టేజ్ ఎలా వేరీ అవుతుంది చూడండి. ఇఫ్ యువర్ ఇన్పుట్ ఈజ్ పాజిటివ్, if your input is 0, your output is also 0. But your input is going to in the positive direction, it is varying in the positive direction, but your voltage is varying in the negative direction. Why? Because it is varying in the negative direction. Always you will get in common emitter amplifiers, what you will get? You will get inverted output. That means you will get the output in coordination with the input, but the phase angle of the output will be 180 degrees out of with the input. And this output voltage is swing. And here for the large signal, for the large input signal, ikkada chudandi, this signal can swing a large distance. Further it can swing further. అర్థమవుతుందా? అంటే ఏంటి, ఇక్కడ దాకా నీకు వేరియేషన్ కి ఛాన్స్. And this also it can vary from this point to this point. And there is a chance of variation from this point to this point. That means the swing is very less. Your output voltage swing is very less, but this voltage can swing further, such that the power of the output is going to be increased. So that is shown here. It is a large swing. Your input is a large input voltage and your output is also a large output voltage with a large swing, with a maximum swing, If it crosses this value, some distortion will occur. So this is about the analysis of the Class A amplifier. Now we are going to see what is the efficiency of this circuit. So what is the measurement of a power amplifier? So power amplifier measurement is going to be its efficiency, and a most efficient power amplifier will be used in the audio amplifiers. That is the reason which class of amplifier, power amplifier is more efficient, that is going to be used in your circuits. So now we are going to calculate the efficiency. So what is efficiency? Efficiency ante samarthya అని చెప్పొచ్చు, and it is represented with eta. So power efficiency we are going to calculate. So efficiency is equal to P output by P input, and this is going to be your DC power, and this is going to be your AC power. If you keep into 100%, then you will get eta in percentage. You will get eta in percentage. Now, what is the input power? We know that power is equal to V into I. We know that power equal to V into I. So what is the DC power? Input power is nothing but DC power. So PI is in DC A power. So what is the DC source we are having? VCC, and the current is going to be average current flowing due to this VCC. Average current flowing due to this VCC, and this average current is nothing but you have calculated, you have given without signal ఇవ్వకుండా మనం VCC ఇవ్వడం వల్ల we got a current which is called IC, and that is nothing but ICQ. Operating point value ఏదైతే ఉందో that is ICQ. So this is nothing but the DC current value. This is nothing but the I average. What is the meaning of I average? I average is nothing but DC value. Suppose ఇక్కడ చూడండి, ఇక్కడ నాకు ఇది ఒక యాక్సిస్ ఉంది, ఇది ఒక యాక్సిస్ ఉంది. నౌ ఐ ఆమ్ హ్యావింగ్ ఎ వేవ్ లైక్ దిస్. నాకు ఒక వేవ్ ఇలా ఉంది. ఈ వేవ్ ఇలా ఉంది, ఒక సైనుసాయిడల్ వేవ్ అంటే సపోజ్ ఇక్కడ ఒక నాకు 5 అనే వాల్యూ ఉంది. ఇది ఇక్కడ 10కి వ్యారీ అయింది, ఇక్కడికి వచ్చేటప్పటికి 7కి వ్యారీ అయింది, ఇక్కడికి వచ్చేటప్పటికి సమ్ 2 డిఫరెన్స్ కదా 3కి వ్యారీ అయింది అనుకున్నప్పుడు సపోజ్ ఐ కౌంట్ ఆల్ ద పాయింట్ వాల్యూస్ హియర్. ఎన్ని వాల్యూస్ ఉన్నాయో అన్ని వాల్యూస్ అన్నిటిని యాడ్ చేసి డివైడెడ్ బై నెంబర్ ఆఫ్ వాల్యూస్ వేస్తే ఐ విల్ గెట్ ద యావరేజ్ వాల్యూ. అంతే కదా. వాట్ ఈస్ ద ఫార్ములా ఫర్ యావరేజ్ వాల్యూ? సమ్ ఆఫ్ ద శాంపిల్స్ డివైడెడ్ బై నెంబర్ ఆఫ్ ద శాంపిల్స్. సో ఆ యావరేజ్ వాల్యూనే ఇఫై. సో ద లైన్ of this sinusoidal wave is nothing but this is the average value. So in the same way average value is nothing but DC value. Average value is nothing but DC value. So ee line anedi DC e kada, ivi varying. This is a straight line. Line is nothing but a DC value, direct current value. Andukane to save the power, what we will send is this type of waves. ఇక్కడ average value anta 0, ఇక్కడ average value anta 0. So power saving కోసం transmission communication systems లో we prefer this type of waves to be communicated. Now, so what is ICQ? ICQ is nothing but I average. I average is nothing but the current due to this voltage source, the current flowing in the collector due to this VCC. So which is nothing but VCC ICQ, which is nothing but VCC into ICQ. Now, if I apply any AC signal also, my current is not varied much. It is not going to change much. అందుకని చెప్పేసి నువ్వు ఏసీ సిగ్నల్ అప్లై చేసినప్పటికి కూడా your current is going to be ICQ. Your current is going to be ICQ. Next. So to find the output power, AC power, we are having 3 formulas. And you can have RMS power, peak power or peak to peak power. అంటే 3 types లో నువ్వు express చేయొచ్చు AC power. So this P output, that is AC power output, is going to be of 3 types. ఒకటేమో VCC RMS which is nothing but, sorry, VCE RMS into IC RMS. This is the first type. Second one is దీన్ని మోడిఫై చేసుకోవచ్చు. ఎలా? పవర్ ఈక్వేషన్స్ తెలుసు మీకు. P is equal to V into I, P is equal to V square by R. ఎందుకని? దీన్ని ఏమని రాయొచ్చు? V by R, V into V, V square by R, and P is equal to, దీన్ని ఏమని రాయొచ్చు? I into R, అంటే I square R. 3 types రాయొచ్చు. సో ఇప్పుడు నేను దీన్ని VCE by R అని రాశాను అనుకోండి. అప్పుడు ఇదేమవుతుంది? VCE RMS square by R, or IC RMS square into R. So I can have, this is the RMS power. Next, peak power. So what is peak power? Peak power is going to be, అంటే ఈ ఆర్ఎంఎస్ని పీక్లో ఎక్స్ప్రెస్ చేస్తాం. ఆర్ఎంఎస్ని పీక్ వాల్యూస్లో ఎక్స్ప్రెస్ చేస్తే వి పీక్ బై √2 ఇంటూ ఐ పీక్ బై √2 అని వస్తుంది. సో దిస్ ఈస్ గోయింగ్ టు బి VP స్క్వేర్ బై 2 లేదా IP స్క్వేర్ బై 2 లేదా దీని ఏం రాసుకోవచ్చు? VP IP బై 2, which is nothing but 0.5 VP IP. అంతే కదా? నెక్స్ట్, పీక్ టు పీక్. సో if we are considering peak to peak, then my peak to peak, V peak to peak into I peak to peak, ఇక్కడికి వచ్చేటప్పటికి 2√2 వస్తుంది. సో ఇట్ విల్ బి VPP into IPP peak to peak by 8. దీన్ని ఏమని రాయొచ్చు? దీన్ని 8. దీన్ని ఏమని రాయొచ్చు? V peak to peak square by 8R. అంతే కదా? ఇంకా I peak to peak square 8, sorry, by 8 into R. ఇది రాయొచ్చు. So these are the versions of expressing a power. If you know the peak value, you can substitute this form. If you know the RMS value, you can substitute the previous form. If you know the peak to peak value, you can substitute this form. So there are 3 varieties of equations. Now which equation we are going to take? Let us have P input DC is going to be VCC into IC. This is our value. Next, if you take P output AC is equal to VCE peak to peak, comma, voltage into ICE peak to peak by 8. ఈ ఫార్ములా తీసుకుంటాను. సో వాట్ ఈజ్ మై VCE peak to peak? పీక్ టు పీక్ VCE పీక్ టు పీక్ ఎంత వస్తుంది? వాట్ ఈజ్ మై VCE పీక్ టు పీక్ అంటే అర్థం ఏంటంటే ఇక్కడి నుంచి ఇక్కడ వరకు, అంటే ఇక్కడి నుంచి ఇక్కడ దాకా ఎంత వాల్యూ ఉందో దట్ ఈస్ కాల్డ్ VCE పీక్ టు పీక్. సో హియర్ మై VCE పీక్ టు పీక్ ఈజ్ గోయింగ్ టు బి VCC. మాక్సిమం ఎంతవరకు వెళ్తుంది? నా VCE పీక్ టు పీక్ ఎక్కడి దాకా వెళ్తుంది? maximum it will go up to VCC. It can go up to VCC. My maximum value is VCC. So here VCE peak to peak is your VCC, maximum value is going to be VCC. And what about this ICQ peak to peak? IC peak to peak. This is nothing but IC peak to peak. So what is IC peak to peak is going to be here. We can see that. This is ICQ. This is VCE, ICQ operating point. So ikkadi nunchi ikkadiki enta swing undo, ikkadi nunchi ikkadiki kuda anta swing. So what is the peak to peak value? Twice of ICQ. What is the peak to peak value? Peak to peak value is going to be twice of ICQ. That is the reason we have to select ICQ such that it is half of the maximum value. It is half of the maximum current. So here, what is this IC peak to peak is going to be? Twice of the ICQ. Twice of the ICQ current by 8. So what is your P output is going to be? P output is going to be, so that is output power is going to be VCC into ICQ by 4. Now what is my efficiency? Efficiency percentage is equal to P out AC by P in DC. That is into 100. So that is nothing but what is P out AC? This value. Divided by, so this value P out. So what is P in? P in is VCC ICQ. So this cancel aithe naaku enta migilindi? My value is going to be 1 by 4 into 100. That is my efficiency is equal to 25%. My efficiency is 25%. That means if you give 100% power at the input, you will get only 25% of the power. So this is nothing but a very poor efficiency. Enduku poor efficiency antanante? If you can utilize the maximum swing, then you will get this value. Maximum swing ni utilize cheskuntene ee value. If your designing is somewhat changed and it is not utilizing the maximum swing, if your swing is this much only, then you will get only 5%, 7%, 12% efficiency. So this is not at all useful power amplifier. So we go for the next amplifier, that is nothing but Class A amplifier with a transformer load. That means for the same amplifier, if your load is a transformer, then your efficiency is going to be improved. Your efficiency is going to be improved.